Today we are switching from finite element coding, structural mechanics to user interface design. So we're going to talk about how to implement user interfaces in Python, and we're going to use something called PyQt, or Qt for Python, to implement this. So PyQt is a module in Python, just like CalFem, that provides you with a lot of tools for designing user interfaces. So first, a bit about our user interfaces. So as you know, there are several platforms for designing user interfaces on the desktop. So we have Linux, we have Windows, we have Mac OS. And unfortunately, all of these operating systems do the user interfaces their own way. And that is not always doesn't make it easy for us as programmers. So on top of these, for example, on Linux, there is something called X11, or today it's called Wayland, which is a user interface library in C for implementing user interfaces. On Windows, we have something called Win32 or WinRT, which is the Windows similar toolkit on Windows, also implemented in C. And on Mac OS, and also actually the iPhone has something called UIKit or NSKit that implements a library for user interface design as well. And if you want to implement an application that runs on all of these platforms, you need to do one application compiled with code for X11, one application with specific code for Windows, and then one specific application for Mac OS. And of course, this is not ideal. We want to have one single source code that we can deploy on every platform. So if we remove these here, and we add some layers here, and one layer we put on top is something called Qt. And Qt is a C++ library, which is implements a separate layer that kind of hides the platform details from the user. So here we have, you write code only once, and you don't have to change it on the different platforms. Of course, we are using Python in this course, so we need something else as well. So on top of this, we add something called PyQt, and that is also called a Python binding. So it's a binary module in Python that connects to the C++ library Qt. So with this, we only have to write one single application. So Qt is a platform-independent user interface library, and it abstracts all the user interface concept into a single library. So you don't have to call any of the native functions of the user interface library. And also it adapts to the current platform. So if you're running on a Mac, it looks like a Mac. There's no you can't differentiate the Qt application from a Mac application. Same thing, if it runs on a Windows application or a Windows operating system, it will look like a Windows application. Same thing in regards to Linux as well. Another feature that you can do with Qt is that you can style the user interfaces to look something different as well. So you can make it look in your own custom design as well. Also, all the events when you work with the user, like clicking, moving, dragging, is handled using something called signals and slots. So if you press a button, there's a signal sent, and you can connect that to a slot where you have your own code. And that is also implemented in Python, so you can connect your user interface with your code. As I said before, Qt is a C++ library, and to be able to use it, we require something called a binding, which are binary modules that connects to the C++ library and provides a Python-based module library which we can talk to from our Python code. Unfortunately, there exist several of these bindings to Python. So we have PyQt 5, which we're going to use in this course. There is something called Qt for Python, and there is Python Qt. So if you work a bit in this world with open source, you can see that there is always, if somebody is not happy, they will design a new library. So you have a proliferation of libraries. The fortunate part here is that as the Qt C++ library doesn't change that often, so most of these libraries will provide the same functions, same classes. So regardless of which of these you choose, you can program in the same way. And what is kind of key thing, what is different, what we have been doing up until now, is that when you have coded your code now, it starts from one point in your Python file, goes through and finishes, and that's your program currently. When you're doing user interface applications, you have something called an event loop. So the application sits still, waits for you to do something. So if you click a button, the program does something. Or if you move the window or enter some text, there is a loop that processes all these events and dispatches that to your code. And when the last window finishes, the loop exits. So this is how this can look. So this is just a pseudocode. So this is not an actual Qt application, just kind of to show you how it works. So you have a flag here, running is true. So long as running is true, we will check for an event. Has anything happened in the user interface? Is there a mouse click? Is there a key press? Is there something else that happens? We get an event. So this function here checks for any events, and then it returns you an event object. And then you can check the event here. So if the event type is a button click, then we have to do something. So we have to handle that button click. So we send it along to functions that handles this click. And then you have a lot of these checks here. And then finally you have something called, that checks that if the user closes the window, there is an event sent app quit. And then we set running equals to false. And then you see here that this loop exits and the application exits as well. Yeah. So can we solve this with the bindings in some way? So we don't want to have to specify PyQt 5 or Qt for Python or in our code. And there is a way of doing this, and there is a special additional module called Qt-Py. So it's the reverse of PyQt. And that checks for install Python bindings. And you don't have to think about what actual Python bindings installed, because that will be handled by this Qt-Py module. And then you can have a single source code with a single Qt import that will choose the correct binding for you automatically. So the code, so for example, I missed one slide here. Okay, but so in normal case you will have PyQt 5 here, we just import star. But now instead you have this additional word here, Qt-Py, and that will handle that import for you automatically. So if you see something in PyQt 5 import in the code on the web, you can replace that by using this module here. And that means that you can run this application anywhere where there is any Qt library. And here you can also see that how the main program of a Qt application looks like. So you have this if name equals to main, which I talked about before. So when you run this as a script, the name will be main, and this will be main program. So the first thing we have to do when running an application is to create an application object. And that is when we create a Q application. So this is a class Q application. We create an object of that type. Sys argument here, that is, if you have some command line arguments, you pass them along to this application. You don't have to care so much about this now. So that is kind of the mechanism that creates the kind of binding to the operating system and sets up the structure that we need to run. So we will see something on the screen. We need to create a window or a widget. So here is a widget class here, and widget is the base class of everything that is user interface in Python. So we create a widget here, and then we show it on the screen, widget show, and that will bring up the window on the screen. But the thing is that we can't run this currently because nothing will happen, because we don't check for any events or any clicks. So in the final part here, we do app.exec. This function here is the event loop. So we don't have to do the event loop ourselves. We just call it here. it goes in here and it will block here until the last window has been run. And then this is just a way of nicely terminating application. We can just have this one as well without that sys exit here. But remember, this one here goes into the loop and sits there until the application has been done. So I will show how this looks in code as well. So here you can see same code. We have Qt here, create an application, we create a widget, and we run this here. It brings up a window. So this is our application. Now the event loop is running. It can already handle, for example, you can resize the window, you can maximize the window. All that stuff is built into this application object. So it handles the maintaining of the window on the screen. It's not much happening here, so we need to provide it with more information. But this is what the basic functionality of Qt handles for you. So you don't have to know how to create a window in Windows. You just have to instantiate an application object, instantiate widgets, enter the event loop. And now you will need your take advantage of the knowledge you have in object-oriented programming. So Qt uses a lot of classes to implement the functionality. So QWidget is the base class for all the user interface objects in Qt. The widget can itself contain other user interface objects, so you can add stuff to it, just like a list. If there is no parent window, it will create a window. So if you create a widget on alone, it will create a window automatically for you. And you can also derive your custom application window from QWidget. So that is usually what you do when you start. You create a window class that derives from QWidget, which provides you all the functionality to create a window on the screen. So I made this today here just to kind of clarify a bit how the relationship between the different things in Qt. So on top here, you have the QWidget that has the functionality to create a window. The window itself will own and manage a lot of objects here. So you can have a line edit here. I will go through all these controls later here. A label, a group. And a group can contain other controls as well. So this way you can create a user interface structure to build up your user interface. And all of these controls, they know how to draw themselves on the screen. They know how to receive events. They know how to interact with different aspects of the system. So the first part when you create a new application in Qt is to create your own window class. So in this part here, you create my window and I derive it from QWidget. And that means that my window class will inherit all the functionality from the QWidget class. Then I have to create a constructor here and call the constructor of the QWidget here. That is called the super init here. That is where I call the QWidgets in constructor as well. Then I have a habit of separating the user interface design into a separate function here. So init GUI will contain all my user interface function. Here in that function, I will create all my user interface objects. Here, I also set the geometry, which is the window size. And I can also call here set window title, which is part of the functionality of the QWidget. And I set my own title here. And I also automatically show, so I don't have to explicitly call show to display the window. And this is the second example. You will get all this code is available also on the web page. You can download it and experiment with yourself. So, so here I have my window. Now you see also, I don't do window.show here because I've already done that in my init GUI. So running this application now will bring up the window. And now you can see that the geometry is different. It's 300 by 300. No, it's positioned at 300 by 300. It's at 800 pixels wide and 800 pixels high. And you can also see that it has my title here is changed as well to my window. So an empty window is not something fun to work with, so we need to add something more to it. So the next step, we will add controls to it, so buttons and text controls. And here you can see here I have, this is the init GUI again, and then I have my geometry here, and then I add self.button. And the important here is to have self, because self, that attaches this button to the window. So when you create a window and you create a button, it will be added to the window. And Q push button, that is a control for creating a button that you can press. The first parameter here is the text on the button, and then self here is the owner. So I want this button to be owned by the window. So that I pass along this here, that is the parent or owner of the window. The tooltip, that is a special box that comes up if you hover over the window. It will bring up a hint that shows what you do. You can set a size and you can move it to a certain position. Then I show it here. Okay, so this is sometimes a problem when I have with high resolution on Windows here. But there is a button here, even if it's small. And I can press it, nothing happens, of course, but you see it, you can already interact with it by, if you move it over, you can see it highlights. And then also if I hover along, it will show you the hint text. So having a button is not enough. We need to be able to connect clicking the button to the code that we write. And all the Qt controls in Qt have events or signals that they can send out when you click them. And the button here has a signal called clicked, pressed. That is when you hold the button down. For example, the list box has a signal called current row changed. And that when you click on in the list box, every time you change the row of a selected item, it will call this signal. And that signal you can connect to your own code. And connection to your own code is done by the connect method. So there is a property called clicked on the button, and there is on that click there is a connect, and here you just attach your own function here as a parameter, and that will, when you click the button, it will call that function. So let's see here if we go to number 4 here. So now I have you see I have clicked on button clicked here, and if I go down, you can see here I have a class method here called onButton clicked. Self here, because this belongs to the class, and I just print out hello here when we click on the button. And then here you can see here I have self.button click is the signal I want to connect, .connect, and then I give it the function that should be connected to this button. If I run this now, I get this minimal button again. Then you can see if you look at outputs here, if I press here, it produces hello here. So now I have made a connection from the button in the window to my own method. And this is the basic principle we are going to use when we're building a user interface. If you create a menu, you will connect the menu to your own functions, and so on. And also, I will also provide some links here. All of these classes have a lot of methods on them. So to program, you need to know what methods you have. And you can see here that this is the Qt for the widgets, the widgets module. And here is also there a reference documentation here that you can look at all the classes and all the methods that you can use in these classes. But because they inherit from the same base, most of the usage of these objects are the same. So there is a set text on many other controls. There is a text method to get the text back. So they're very similar. Let's see here. So there are some methods that are common to many of the controls. So there is, for example, if the control is visible, that is, it's drawn on the screen. You can set here set visible to false, then it's not shown. It's still there, but it's not shown. You can check if it's visible using is visible. You can disable the control, and that means that it's shown on the screen, but you can't interact with it. You can use set enable true or false. You can check if it is enabled. If you have a text control, you can move the cursor to the text control using the set focus. That will focus the text control and make sure that the cursor is blinking in that method. And then there is, if you have a control that can handle text, usually the method is called set text to set the text and text to retrieve the text from the control. So in this example here, we have 3 buttons that we add, and we give them different names to distinguish them in our code. We connect the button 1 to the button 1 click function, button 2 to button 2 clicked. We don't do anything with the button 3, just show it on the screen. And if you click the number 1 button, it checks if it's visible. If it's visible, it sets visible to false. So it kind of, and if it's not visible, it sets it to true. And in this case here, we have if button 2 clicked, it checks if button 3 is enabled, then it sets it to false and set enable here. So this will illustrate how you can use set the visible, these properties on all objects here. So controls. Okay, it's minimal again. But if I click the first one here, you can see that the second one disappears. That is the set visible, that removes the control. It's still there, but it's invisible. And if you press it again, it shows up again. If I press the second button here, you can see the third button kind of disappears. It's still shown, but you can't interact with it. And that is tools you can use. For example, if you have a function in your code that the program is not in a state that you can use that function, you can still show the user there is something here, but not everything is fulfilled to be able to show that control. Then you can use set enable and to kind of disable the pressing of that button. Connecting the event, we showed already. You can also have different styles of your windows. So in this case here, it's on a Mac. You can set here. This is a standard window here. You have all of the controls here, like maximize, minimize, close. Then you have the dialog here. That is there you can't. There are some you can't resize this, for example. And then there is the tool window here that can be used to display a toolbar window of sorts. So let's try out normal window. You probably see these already. Just a standard window. You have all the controls. You have minimize, maximize, and close. If I change it to dialog, you can see here that I don't have a maximize button, and you can't maximize on the screen. And there is also a help button here to get help on your dialog. And then you can use tool here to create a toolbar window. And this has a smaller close button here and a smaller caption here. It's also possible to when you start application to maximize the window. So if you want the application to show on the entire screen, you can use Qt window maximize here, window state. There's also one called Windows full screen, which I will show you, that will actually put the window on top of everything. So it actually covers all the user interface parts of your operating system. Let's start with this one here. Okay, what happened? So this is a maximized window, covers the entire screen. And then you have set window full screen. This is a bit dangerous. You need to know how you close a window, which is Alt F4 to make it. So if I run this here, you can see it takes up, there's no title, anything, it's just over the entire screen. Then I have to do Alt F4 to close it like this. So also to make a Windows application or desktop application, you need menus. And in Qt, there is a class structure here, Q menu bar that is added to the top of your, that is the kind of top up container of your menu. And then you add menus to this menu bar and items to those menus. And then for the actual menu item, you add something called a Q action. And the reason we have the Q action is because we also have toolbars, and we don't want to duplicate code. So toolbars and menus share the same actions. So you connect the same actions to the menu and also to the toolbar. So I think I will display these here. This is a program with a menu bar. And the difference here we can see is that we have, instead of Q widget, we have Q main window, because the normal Q widget can't handle menus. So we need a special class that can handle that. And Q main menu can handle, or main window can handle toolbars and menus. And the first thing we do is to create our action. In this case, we have my action. This is the text that will be displayed in the menu. This is the owner of the action, which is our own window. We set a shortcut here. The shortcut is the keyboard that you can use to access this action with as well. And then we do action triggered. So this has a different signal than the button. And we connect it to our own method. Then we add this action to the self.menu bar function property here and add menu. And then this is a file menu. So this is the main menu. And then to the file menu, we add this action. You can see here, create action. Then we create a file menu in the menu bar by using add menu here. And then we add my action to the file menu. So now you can see we have a window and we have a menu here. And we have a sub menu. You can see here that the text is the text in action, and then you can see here the control C is our shortcut. And if I click here, it will display a message box. I can also press the Control T on the keyboard. It will also display this. So it's always good to provide users with both a visual method of executing something or running something in application, but also having a shortcut that you can, if the user is more familiar with program, you learn the shortcuts and it's quicker to work with the program. Then we can also add a toolbar. So self add toolbar, the main window has an add toolbar method here, returns you a toolbar object, and to the toolbar we can add the same action here. So here we have our action is the same. We have a menu bar, we add the action to the menu bar, and we add the action to the toolbar. Now we have this minuscule again. If I press this one here, it will run this as well. The nice thing with toolbar is that you can actually move it around and dock it here. That is built in as well. Another thing that is problematic here is the scaling here of the user interface. What's that? Yes. So one thing we have done up in is we added the controls with X and Y coordinates and a fixed size. That has a problem here. If you resize the window, the controls will kind of stay in the position that you put them on. But if you have a window, you probably want to move your controls around to adapt to the size of the window. And to handle that, we need to do something more with our code here. So the first thing I showed you now is called absolute positioning, and then we have something called sizers. And sizers are special controls that can rescale and move existing controls in the window. So if you add things to a sizer, it will automatically move them around according to some certain rule. So we are going to do this here. So we have something called a box layout, which is the box layout. It's kind of a box where if you put something in that box, it will organize them vertically. So it looks something like I show you here. If you add them to, the buttons will just be added on top of each other. You can see here that we don't set any position information here. We just create the controls, add them in the box, and the box layout will automatically arrange them in the window. And then we set on our main window, we set the layout here to our virtual box. So if I change the window size here, you can see here that it arranges the buttons automatically to fill out the entire window. It also prevents it to shrink too small, because there is, on each control, you can set a minimum size or a maximum size. And in this case, the button is set to be expanding in the vertical direction, but it has a maximum size in the vertical direction here. And there's also a minimum size that it can't go below. And of course, there is something called a HBox sizer, which does the opposite. It arranges controls in the other direction. You can see here they are arranged in that direction. Then you can combine these two. So you can have one sizer can contain another sizer. So you can have a vertical sizer, and one row could be a horizontal sizer. So for example, here I can have the main sizer is a vertical one. So these are all sorted vertically. Then I have a horizontal sizer that I've added here as the last row. And that arranges the controls, these controls in this direction here. Then you can also add springs. So if I don't want these buttons to kind of fill up the entire space, I can put a spring here that pushes this button up on top, and that is called add stretch. So here you can see I create my buttons here, 8 buttons here, button controls, and then I have I add them first to the virtual box layout here, the top of the cover. Then I add create an H box here, which I add 6 to 8. And then I add HBox B layout to the VBox layout here. So I insert this one as a control into this VBox layout. So the layout itself is a control that you can put in other controls. And now you can see here that I have. You can also see that I put the stretch here and I put the stretch here. When I draw here, this will expand and push this button onto the right and keep this button to the left. And this one here will push the buttons up and keep those below here. Then there is another layout called the grid, which you can give a control coordinates here. 0, 0, that is the top left here. You can have any coordinate system. You don't have to have a pixels here. So it's basically the 0 row, first row, second row, and so on. And then you can just put the controls and give each control a coordinate in the grid. And this layout will kind of arrange them in different ways. And here you can also set stretch in different direction here. So I have put stretch here that this one should expand and the other one should be contracting. So if I run this one here, you can I think it's a good idea if you download these examples and try them yourself and experiment a bit with the settings. So you can see here that if I resize here, this one will expand and those will contract. So you can set this up in different ways. So this could be something else than buttons. So you can have some other controls here on the left. You can have a text editor here, for example, some other controls here, and it will automatically rescale them to your window. Another thing that is built into Qt is a lot of standardized dialog boxes that you can use. And you have the ones we are going to use in this course is message dialogues. If we want to display a message that, for example, something went wrong or some informational, you use these message dialogues. At some point in your code, you want to ask the user for a file name, then you can use the file dialogues. And there's also a way of selecting colors, and there are multiple other dialogues you can use. And the idea with those is that they will bring up the operating system's file dialog. So if you're on a Mac, you will get a file dialog that looks like a Mac. It is the Mac file dialog, and on a Windows, it's a Windows file dialog. So here, we'll use the message box to do queue message box. This is a general class for this, and then dot information. Who owns the window, which is our own window here. The message. There's a text here, the title, and the ouch is the message coming out here. So what I have here is I have this menu here, and I just call it when I select the menu here. And if I run this now, you can see it brings up a standard Windows dialog box, which closes when I go back here again. Then I can do, if I want to do that something is really critical, I can use the queue message box critical function, which should be used sparingly because this is not something you want to show the users too often. And you get this red button here. And then something should have gone really wrong if you want to show it. If it's just an information that calculation has finished, bring up an information dialog instead of a critical or something. Because usually people get a bit scared when you show user dialogs boxes like that. You also have here a warning. That could be something that, do you really want to erase your directory? You get this warning triangle here. Then sometimes you want to ask a question. For example, do you want to continue? Yes or no? Then you can use the question function here, and here you give it. So this is the title here. This is the question that you want to answer, and here you can also supply. I want a yes button. I want a no button, and the default should be no. Then it will return result here. And then you can have an if statement here. So if result is Q message box, yes, do something. Otherwise, do something else. So you can see you get this one here. You want to remove, yes or no. And then you can see here, you pick yes. So this could be, for example, if you know that something is, you want to verify the user, is this really what you want to do? Yeah, put a question dialog box up and ask the user for advice. Then we also have, if you want to ask, for example, which file should I open? Then I can use the get open file name. And then you specify here which files to open. In this case, you have flow input files, for example, a groundwater flow. Here you can specify which extension you should display in the dialog box. That will filter only show files with a .inp ending. And if you select something, it will return a file name here. And then there is a second parameter which we will not use here. And if it's empty, the user canceled the operation. So if I do file, open dialog, now you can see here I get the standard dialog box from Windows. But I also, you can see here I have a dialog box here showing what files to display. So in this case, I don't have anything in this, no IMP files at all. If I do start or start here, I can select this one here. And if I press the open button here, you can see here it returned the search path of this file. And if you press the cancel button, the file name will be empty. So you can check if the file name is empty, the user didn't select anything. I think we stop there and take a 15 minutes break and then continue after that. Forgot to turn on my video. So this part we will talk about the controls that you can use to combine to create a user interface. It's like a tool chest of different things that you can use to provide the user interface. The first one we already talked about, the button. Now there is also one called checkbox and a radio button, and these can be set to be buttons with a state. So you can compare an on-off button on for the light, for example. The checkbox is one of them. You can use check state to set the check on and off. You can query what if it's on or off using the check state function. There's a radio button which is a bit special. It's the same as a checkbox, but only one of these can be selected at the same time. So they're you have to put them in groups to be able to use them. I think I will show them in code instead here. Also, I realized I can show you what I did to fix the problem with the scaling here. So I will put them check them in. So if you check out the examples again, they will all contain these statements here. So this is high DPI scaling. That means it can scale the user interface if there is a very high resolution screen, and also that will use high resolution pix maps to display graphics. So if you add those, the user interface will look okay. So here I have a checkbox I created just like a button. Checkbox, the text that I want to display, owner, and I get the box here. And then I have a method here called setChecked that will set the check in the box. And then you can also connect a signal called state change. So if you click on this control, it will call this method. It's not necessary to have a signal on checkbox. You can also query the state when you want the user to do something. You just query the state of this, so you don't have to actually connect it if you don't want to. So if I run this, now it's a bit bigger. You can see here, and then if I press here, you can see here that it calls this method here, and it queries the state of this here. So you can see here that I have in the signal here, if self checkbox check state. So if it's checked, this will return true, and otherwise it will return false. Then I have the radio box. Here you need to have multiple of these. So in this case, you have radio button 1 here, second radio button. I connect the clicked here to these to the same signal actually. That is also possible. So you can have multiple signals handled by a single function. And here I just check if is checked, then I do something here. But the thing is, you can't see in the code here is how it works when it's running. So in this case, I have this one is checked. But if I press the second one here, you can see here that this one is disabled or unchecked automatically. So if you have multiple radio bugs, only one of them can be checked at the same time. So it's a multiple choice, but you can always check one of them. And if you want to have a multiple of these, you need to group them into group controls. Otherwise, they will. The more you have, only one of them can be checked at the same time. But if they're grouped into groups, each of them, these groups works independently. Another control that can be important is the combo box. It's a multiple selection control, just like a radio button, but it is a small control. If you click it, it will drop down a list of options that you can select. It can also act as a text box for providing text. And the reason for using this, if you want to have the user to select and you don't have too much space in your window, this is a good control to use because it takes up little space and you can have a lot of options in it. And then the selection list can be connected to the current item change. So if you select something, this signal will be called. You can also query the function current index to get the currently selected item. Combo box there. So you can see here that I create a combo box here. I add stuff to it. So I have ultimately option 1, 2, 3, and 4. I can set the current index here to 3, so 0, 1, 3. So this should be selected by default. I connect current index changed to my function current index changed, which displays what choice I chose. And you can see here that this method here needs a second parameter index here, which will be provided by the call from this function. And then you can see which one of them was selected. You can also get the text in the box using current text. You can see here I have a small box here, looks like a button with a small indicator. If I press here, you can see that it drops down the different options I selected here. And if I click here, another control that can be useful sometimes is a slider to quickly select between two values. It could be, for example, the coarseness of the finite element grid. You can have a slider that you can slide high and low or options. And there's also options for setting the range start and stop and the step. I will go to this one here as well. So here I create two sliders. You can have the slider can be vertical or it can be horizontal. So you can set qt.vertical here that I want a vertical slider. I want to have a maximum value of 100, a minimum value to 0, and I can set the current value to 50 here. And I can do the same thing kind of horizontal here as well. Then you can connect the signal value changed. So when the slider changes, this one is called, and I attach it to my own code here and just print it out in my output window here. The current value here, which you get with the dot value method. It's a bit hard to see, but you can see there is a slider here and you can draw it back and forth and you can see it changes the value, and here it changes the up and down value here. The list box is very similar to the combo box, but it actually shows you all the items that fits in the control you design. When you add a large number of options, the scroll bars are added to it, so you can scroll up and down. And you can also add an option for if you allow the users to select multiple options in that list box. I should explain first the code. So I create a list widget here. I add actually 100 items here to this list box with some text in it. I set the current row to 2. And I can also connect current row change, connect here to the method here. And you can, to this, you can see here I have current item here. It's the same basic settings that you have for the combo box. But now you can see here that I have, there's a scroll bar here because there are more than 100 here. It doesn't fit in this, so I can scroll up and down. And you can also see that 0, 1, 2 was selected here. If I click here, it says you choose 7, and a row contained this text. Line edit is something that you will use in this course, definitely. So this is a text box where the user can enter a value. So this is basically how you get input to your code. You can set the text in the box using the set text, and you can retrieve the text using the .text method. So QLine edit, I create it here. I set the text to text, and then I can do. When I click the button here, I will just display what the current text in the line edit is. So you can see here that I have a text here. I can type anything here, and if I press this button here, it will display the text in the button here. The only thing you have to think about here is that all the input from the user is in strings. So you need to check the input before you convert it to a floating point. So there, you need to do some error handling, which I come back to shortly here, which I will come into now here. So now you have learned some of the controls. So I will try to give you one way of connecting your model and your user interface, because now you have the means to create a user interface using all these objects, but now you have to get the data from the user interface to your model. And what I usually do is I try to collect all my user interface interaction in 2 methods. So I have update controls for taking my data from my model and filling the controls with data. And then when the user clicks OK or run or anything, I go to update model. That will convert the things in the user interface and to values in the model again. So I have a 2-way communication. I collect everything going to the controls in one method, coming from the controls in another model. Yeah. So here I will do a simple model here. I have a class here with values here. I have a floating point value, I have a Boolean, I have an integer, and I want to just print it out here. And now I want to create a user interface for this. So I design my user interface here. This is from a tool I will show you shortly, but I have text value, I have an option here, I have some radio buttons. So you can see I have update controls, takes your data from the model and populates the controls. So I have here update control, so text edit, set text, self model into the user control, and I can use in this case this is already a text value. Here I convert from a floating point using the str method, and then I check here if you have a Boolean value, you have to kind of use check them to actually enable the checkbox. The other way around, you have to go. Text is no problem, it's just assigning the text. But if you have a value here, you have to do float to convert it here. And here you also need, I will show you here how you handle this error handling as well, because this could be wrong. The text here can be containing something that can't be converted to floats, and that then will get an error. So you need to handle it as well. But the idea is that you have one method for updating the model, one method for updating the controls. So let's do a real application here. So I will do an application that calculates an extremely complicated case of a beam. But you have a lot of functions you need to implement. I want to create a beam, simply supported beam model. So first, and also the idea is that before we do any user interface, the model should be used like this. So I create a simply supported beam model or beam. I can set some properties here on the model. I can do loop over this here to print out the different section values for the beam, print them out in the table like this. So this is a non-user interface version of my model. And now we want to implement a user interface for this. Or implement this. So the first thing we do the model here, and I think you already have done some of this in your code. I define my internal attributes here. And to handle the conversion from float without errors, I actually do something like this. So I have a method here in my class that's called toFloat. I have a new value, that is the value I want to set. I have an old value, that is the old value that the model contained before. I do a try and accept here. So I try float to convert this new value to a float. If it succeeds, B will be assigned. If there's something error here, I will return the old value. So regardless of a user puts in any text string into the control, nothing will happen. It just returns the old value that I gave here as well. If there's no exception, I return the converted value. That is perhaps a bit hard to see here, but then I create my properties here. Returning the value from the model is no problem, just returning the internal attributes. But then I have the setter here to set the property. Then I use my toFloat here. Self toFloat, B here is my new value that the user tries to assign. The old value is self underscore underscore A, the internal attribute. If this goes well, if any error, it will assign the old value to the attribute again. Otherwise, it will assign B here. So in this case here, you can handle errors exactly the same way for every assignment here. And then I have, of course, compute deflections. And here is something you already used here, that you can use shorter variable reference here to handle them in functions like this. So these are, A is a reference to self A.
Här var jag hittade.
Then I want to create a user face that looks something like this. So the user should be able to enter some values here and get a table out like this. So the first thing I do, I import my B model here as BM in my user interface window class or module. I create the B model here in my main window class, initialize my GUI, update my controls, and update the text edit window as well. So init GUI, I create a lot of controls like this, a label that is a text that receives the text edit here, create an edit for each of the attributes of my model. And then I also connect some events here. So editing finished, that is a signal when the user has finished with a text box. It will call this method here. And here you have update controls. We just do set text string self beam A. So in this case, this will convert, this is guaranteed to be a float. It converts to a string, that's the text. The text edit here basically just calls the loop here that we did for printing here, clears the text box, appends the header, and then just loops over the beam here to calculate the values. Update model, we do something like this. So this is actually quite the two float that we did. You see here that we do text here is a string. If we assign the property A here with a string, if we go back to the code again here, if new value is a string with a floating point value inside a string, of course, this float will convert the string to a floating point and return that. We don't have to do anything complicated here. We can just assign the text directly to A, and it will automatically convert to a floating point. So here we just update the model, taking the values that are in the controls, assigning them to the properties of my B model. So here we have model to controls, and here we have controls to model. And then we need to, what happens when the user edits the text boxes? So on editing finished is called when the text control has finished. We call update model to read the text boxes. And then we call update text edit here to fill the text box with values. And then also update controls again. If something was wrong here in the conversion, we update controls again to show the values one more time. Because it could be if you enter an empty value in the control, update model will handle that, but will not update the control itself. This will display the values again. So let's see here if I can run the code. So here is my B model. Attributes here. You can see L here is an attribute that is calculated from two other ones. And if you look at the properties for L, it only has a property. Because you can't set L because it's based on A and B. But you can return L as a property that is calculated from A and B. So if you run this code here, you can see it prints out the values here. So we go to the user interface. We create our B model here, init our user interface. So basically create all our controls here. Then we update the controls. So we take the values from the model and fill the controls, and we calculate the section forces for the values that are displayed. And you can see here that I use a grid layout here to place my controls inside here. So if I run this here, let's see if I can just fix this code directly here. Yeah, it's a bit bigger. Now you can see I have my controls here, my line edits, and I have my table here. So if I change, for example, A here, and I tap to the next, it will automatically calculate the table again. So on edit finish is when you leave the text control, it will call this method, calculate the value, and update the table here. And you can also see here that the user interface kind of scales when you resize this here. So at the end here now, I will show you a really easy way. Instead of writing all the code for defining a user interface, you can actually design it in an editor instead. So for Qt, there is a application called Qt Designer, which you can create a description of the user interface in a file, which you can load in your code. So if you look here, I have a user interface here, the load UI here. And the UI file here is the control, is the description that I can load, and that will generate all these controls for you automatically. So this press me button here is the control inside this one here. And when you load this file, it will create this control for you. So you don't have to create them on your own. You can create them from the description. So what I will do now is I will start Designer. And you can start a tool from the command line in Anaconda typing Designer. That will bring up this window here. And you can select main window. That will create a user interface with a main window class. If we want a user interface just without a menu and stuff like that, you can do widget here. So try this one here. So now you have, this is your tentative window that you want to design. And what you can do now is you can, on the left side, you can see all the controls that you can use in Qt. So there is a lot of them. I'm just going to do a lot of buttons here. So I will just drag in some buttons like here. So you click, drag, release. And by default, it will use absolute positioning of these controls. So let's see here, put this one here. So my kind of, when I use this, I just drag them in approximately where I want something to be and release. And now I can save this one here. I save it to where did it go? Call it form9.ui. Save. Now I can go into my code again here. I will do form9. I've done it many times here. And then I will skip those one here for the moment and just see what happens here. So if I run this, I will paste in. This just fixes the scaling. So, and so you can see here now it opened my form, and you can see it put all the buttons here approximately where I put them here. And if I resize now here, you can see what happens here. They just stay put like this. And this is not what we want. So we want to design these a bit different. So I want to also to create a text edit view here. So I will do, let's see here, a text edit here in the middle. So I will do a kind of a text editor with some controls around it. So what you have to think about now is to kind of how do we divide up this user interface into sizers. So you can see you could think that you have row here, or column here, and column here, and column here, and two rows like this. So what you can do then is you can select the controls you want to group. So let's see, those should be a vertical layout. So I press them like this. And I select this one here, and you can see here, those top controls here shows you that layout vertically, like this. Then I can tell the user interface, so these three here, the text, the buttons on the left, the text edit control, and the buttons on the right, I want them to be layout horizontally. So we can use this one instead. So we select all of these ones here, and we say layout horizontally, like this. Then we can group these bottom ones here as well, layout horizontally like this. Now you can see we have this group here, and we can lay out them vertically. The main window, I click on the main window and I lay that out vertically like this. Now you can see here that it's arranged the controls around this one. Then I don't want them to be spread out like this. I want them to be on the top. So I can use the springs here. So let's put the spring here. And you can see it expanded and pushed the controls up. And I can do the same thing here, like this. And then I want these two buttons here to be on the right, and this one stay here. So I can put a spring here inside that one. So a horizontal spacer, and I just drop it here, like this. Then you can see on the right side here, there is an object inspector. That shows you the structure of your objects. So you can see on the top here, I have my main widget. It's laid out vertically. Then I have a horizontal layout, which is inside here, these three here. No, sorry, it's this one here, the vertical layout is this one here. And I have this one here, and I have this text edit here in the middle. Those are laid out horizontally, like this. And they internally are vertical here and contain these buttons here. And you can see here that they have some kind of names here. So every time you create a control, they get a name. And that is the name it will get as an object in your code. So it's a good idea when you design in Qt Designer that you actually name your controls reasonably. You can see here that I had a press me button here. So I want to create this top button here should be the press me button. So you can see here in the properties section here, is all the properties that the control has that you can control. The name here is the name you will get in your code. So I paste it in here, press me button like this. And you can also see here there is a lot of other things you can change. So all objects in Qt inherit from the Q object, and basically that only has the property, the name of the object. Then you can see here the class Q widget, and the yellow part here is all the properties that are related to the widget class. And if you scroll down here, you can also see here the tooltip. The tooltip what I set manually in the functions before. You can set it as a property here. You don't have to enter that in the code at all. It just comes with this is the press me button. And then you can see here that you have an abstract button. So this is a button here. So this is the class. So the button derives from abstract button, and it has these properties. And the text here is the text of the button here. So I can do press me here, just to show that this is a press me button. And you can see it changes also in the designer. And then here, this is the actual property that is derived, the Q push button implement itself. So most of the functionality is derived in this abstract button. So the further down you go, the more specialized the properties become. So all controls have the yellow part here. So if I press the text edit here, you can see it has the yellow part, that is from the Q widget. Then you can see here that it has properties from the Q frame, and you can change some of the properties here. Scroll area. And going down, you have the Q text edit. So if I save this now, it should load up the same user interface as I showed before. Yes. So I have my push buttons here. It's all nicely laid out. You can also see that it adapts to the user interface of Windows 11 here. So it looks like a Windows 11 application. Has the same style of the controls. Here's a text editor. I can enter some text in it. And if I press here, nothing happens because I have commented this out. So you can see here now I use self.press me button. And you can see we didn't create this on our own. This command here, UIC load UI, actually does the magic for us. So this will load this UI core, create all the objects for us, and add them to the class here. So now I can use this here. I can set the text on it. So now the text in my user interface will change. I will connect the signal clicked to this button press, and just to see if it works here, we try it out. So I changed the text here. And if I press this one, you can see here that it is also connected. So this is the way you should design your user interface now also for this. You do it in the user interface designer. Lay out the code, and the worksheet shows you a lot of that step-by-step how to design, build up a user interface. A tip is also to, when you do some complicated work in Qt or Qt Designer, save often so you have the last entry, because you can mess up the design and it can be hard to get back. So save often different versions of it. I think that was what I wanted to show today. Yes. So let's see here.